This is called fraction busting, okay? We're going to take these equations, and now we've been dealing with whole numbers. We're going to introduce fractions into our equations. Now, our life is going to be a lot harder if we don't know how to bust these fractions or break these fractions, right?
Yeah.
Couple things. The first thing, every single term must be a fraction, right? So if I have something like 2x, how can I turn that term into a fraction? Who could tell me with a quiet hand? How can I turn 2x? Yeah, Tristan, how can I turn 2x into a fraction? 2x over 1. Right? Is there any other number I'm going to put under a whole number to make it a fraction? Yeah.
0?
No, we're never going to put 0. It's just going to be 1, right? Yeah, it's always going to be 1. Whether it's 2x or it's negative 10, right? We're always going to put it over 1. So every single term needs to be a fraction, all right? If there is no denominator, make a denominator of 1. Before we start, we have to find the LCD, which stands for what again? Lowest or least common denominator. We're going to make equivalent fractions, right? Equivalent fractions. If I had 1 over 2, what's an equivalent fraction to 1 over 2? Yeah, Alex?
2 over 4.
2 over 4. What's another one?
3 over 6.
3 over 6, right?
4 over
Am I good? Yes, 4 over 8, we can go on forever, right? Is the amount here changing at all?
No.
No, right? Again, it's like if I wrote my name versus if I wrote my name in cursive. It says the same thing, it's written a different way, right? So all these equivalent fractions say the same thing, they're just written with different numbers, okay? Just a little review. Once we have the LCD and we make all equivalent fractions, we could just cross out the denominators and solve it like normal. It makes our lives so much easier. Let's take a look at what I mean by that. In number 1, I've got negative 9 over 2 plus x over 4 equals 1 over 2. Is every term here a fraction?
Yes. Yeah.
Yes, they are. I'm going to go through and label them just for my own personal sake. Negative 9 over 2, is that a constant or a variable term?
Constant.
Constant. What about x over 4?
Variable.
How about 1 over 2?
Constant.
Okay. I'm going to split my equal sign down the middle, just like always. Okay. Now, do each of my 3 terms have the same denominator currently?
No.
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 Okay. We've got a denominator of 2, a denominator of 4, and another denominator of 2. Okay. Now, with something like this, my hope is that we're able to tell right away what the LCD is. Who could tell me what my LCD is going to be here? Anthony?
4.
4, right? How did you know it was 4 so fast, Anthony? You didn't even write anything down.
Because there was a 4.
Okay, what else? There's also 2. Why isn't it 2?
Because 4 is bigger.
Because 4 is bigger? So if there was a 7 as a denominator, would my LCD be 7?
It has to equal the other one has to equal the same amount as the LCD.
The other one, you mean the smaller one?
Not the big one.
The bigger one has to equal the smaller one?
No, the smaller one has to equal the big one.
The smaller one has to equal the bigger one. Oh, okay. I kind of see what you mean. You're definitely on the right track. Alex, can you fill in that one missing blank we need?
If you look at the multiples of 2 and 4, you can see that the lowest common denominator is 4 for both numbers.
Okay. That's absolutely right. Let's take a look at 2 and 4 for a second. I'm going to do it off to the side here. If I have 2 and I have 4. And now we're going to write out my multiples. What are my multiples for 2?
2, 4.
2, 4, 6, 8, forever and ever, so on. What about 4?
4, 8,
4,
12.
8, 12, blah, 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 forever. Right? We're looking for a multiple in common. Yes? What number did we have in common here between these two?
4.
We've got 4 and 4. So my LCD here is 4.
Well, actually, they both have 12 too.
Yeah,
They
you got the
will,
lowest
exactly.
But the lowest
But
is
L
the
stands for the lowest.
Oh.
Yeah, you got the
Exactly.
lowest one.
I love that you brought that up. I almost forgot to
What
bring
about
that up.
the
Yeah.
highest?
We could keep going and find a bunch of different common multiples or common denominators. We want the least or the lowest Because the smaller the number is, the easier our life is. Yes, that was a great point, Anthony. Other Anthony.
What about the highest common denominator? Isn't there one?
There is not one.
Yeah, but if you wanna
Because
do
these
that-
will go on forever, infinitely, until we can't count anymore.
If you wanna do that, you can.
There is no highest common multiple.
I'll stop counting at 100.
But that's too complicated for us. My LCD is 4. What does that mean? Now that we know the LCD is 4, we want to turn all of these into fractions with a 4 on the bottom. Okay? Do I need to touch this middle term at all?
No,
Why not?
because there's already a 4.
Already a 4 on the bottom. Do I have a 4 in this first term? No. I have a 2. What can I multiply 2 by to give me 4?
Multiply.
Tyler, what can I multiply 2 by?
2.
2. So I'm going to multiply this fraction by 2 over 2. Why did I write 2 twice?
Because you have to do 2 on the top and the bottom for the denominators.
Okay, but why? What is 2 over 2?
1.
1. If I multiply something by 1, am I changing what it is?
No.
No.
Same thing.
I'm just writing it a different way, right? What about my term over here, 1 over 2? What can I multiply 2 by to give me 4? 2 again. So this one's also going to get a 2 over 2. Here in the middle, we don't need to write anything. But I'm going to write 1 over 1. Because I don't want this guy to feel left out. I want him to feel included. So I'm going to also include him with a 1 over 1. All right. Take a look. Take a look. This first term now becomes what? Negative 18 over 4. Okay. Plus, does my middle term change at all? No. X over 4. And what does my last term become? 2 over 4. Do all of my terms have the same denominator now?
Yay.
Yes, they do. What can I now do with those denominators?
I can add and subtract.
Take a look.
Cross them out.
Cross them out.
Oh.
We're going to get to that next, Alex. Absolutely. 4s all go away.
Yay.
Bye bye 4.
Okay? What do we have now? We have negative 18 plus x equals 2. Doesn't that look a lot easier to solve than what we started with? Yes, it does. What do I need to do now to get x all by itself?
Add 18 to both.
Add 18 to both sides. What is 2 plus 18?
20.
So what is x equal to here?
20.
That's right. This is Mr. Church. What's up? Yep. Okay, definitely. Yep. So we get x equals 20, yes?
Yeah.
All right. Sorry about that. So what did we do? We did plus 18, boom, boom, plus 18, plus 18. 18s go away. X equals 20. There's my answer. Just like that. All right. Once we break the fractions, or bust the fractions, right? It's really easy to solve. Just a quick couple steps. We're used to doing it, right? And we get 20. Now number 2 is a little bit different. Okay. What are my 3 denominators here in number 2?
10.
I got a 10. I've got a 3 and a 6. Well, I'm going to look real quick. Does 3 go into 6?
No.
Yes.
Yeah. 3 goes into 6, right? Does 6 go into 10?
No.
Does 3 go into 10?
No.
No. So we got to think a little bit harder with this one.
Get to.
Let's see. I'm going to write out my multiples. I don't want to erase this, but I need to. Who can tell me what are my multiples for 3?
3, 6, 9, 12, etc.
Okay. I'm going to teach you guys a little shortcut too, because this is going to take a while. We got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, blah, 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 blah. What about 6?
6, 12, 18, 24, 30, blah, blah, blah.
Okay. And what about 10?
10, 20, 30, blah, blah, blah.
There we go, right? What's the first multiple we see in common?
30.
30. Boom, boom, boom. We could have kept going to 60, but that's not the least common multiple, right? 30 is our lowest. Now, this is a lot to write out, okay? Especially when we have something like, we don't have it here, but if we had a denominator of like 2 and 18 or something like that, it's going to take forever, okay? So here's what we can do instead. We take a look just at the biggest number, 10, all right? And we write out a couple multiples for 10. So 10, 20, 30, 40, 50, right? Then we look at the second biggest number, which would be what here?
6.
6. Now, does 6 go into 10?
No.
No. Does 6 go into 20?
No.
No. Does 6 go into 30?
Yeah.
Yes. Okay. This is my potential LCD. Now I look at the smallest number. Does 3 go into 30 as well?
Yes.
Yes, it does. So I know that that's my LCD. It avoids writing out all the multiples of 3, all the multiples of 2, all those smaller terms. If we just focus on the biggest one. Now, if we did that same logic over here, right? We focus on the biggest one, which is 4. Does 2 go into 4?
I mean, yes.
Yes, right? So we know that 4 is an LCD. Very, very quick. Very, very easy. Okay? If I look down just preemptively at number 3, right? What's my biggest denominator in number 3? 6. Does 3 go into 6?
Yes.
Yes. Does 2 go into 6?
Yes.
Yes. So what's my LCD?
6.
6. Right? And then we'll go to number 4 in a second.
Oh.
Okay, number 2. Like we said, my LCD was what again?
30.
30. LCD 30, just like that. Okay. Now I need all of my terms to have a 30 on the bottom. So I'm going to multiply them all by a whole fraction specific to that term. Let's go one by one. If I have a 10 and I want a 30, what can I multiply that by? 3 over 3. If I have a 3 on the bottom and I want a 30, what can I multiply that by? 10 over 10. And if I have a 6, what can I multiply that by? 5. Real quick, show of thumbs. How are we feeling about this? Thumbs up so far, it seems good. Thumbs sideways if it's a little confusing. Okay, we're going to do another shortcut here. Are you ready?
Yeah.
What's my denominator on this first term about to be?
30.
What about my next term? 30. What about my next term?
30.
If I have all my denominators the same, what can I do with them? Cross them out. I don't need to write it out because I know they're going to be 30. So I'm just going to cross them out right here. Look at that. Now what we're going to do is solve across the top. 3 times 3x minus 4 times 10 equals 1 times 5. What does that give me? 9x minus 40 equals 5. Look how simple that is to solve for us now, right?
I get it.
You get it. That's good. I'm going to add 40 to both sides, leaving me with 9x equals 45. Divide both sides by 9, and I'm left with x equals what? Boom. Just like that. I'm going to skip number 3. Okay, you guys will do that in a second. Number 4, what do I need to do here in number 4? Even before I find my LCD, Liana, what do I want to do?
You need to turn -2 into a fraction
How can I turn -2 into a fraction, Liana?
by making the denominator 1.
Exactly. I'm going to make the denominator 1. All right? So I know I don't even need to factor this first denominator into my LCD because 1 goes into everything. So I've got 6 and a 4. Which one's bigger, 6 or 4?
6.
6. I'm going to focus on 6 then. 6, 12, 18, 24. Does 4 go into 6? No. Does 4 go into 12?
Yes.
Yep. There's my LCD. All right? My LCD is 12. Make sure you write what your LCD is. Now my first term, my denominator is a 1. What can I multiply 1 by to give me 12? 12. What about 6? What can I multiply 6 by to give me 12?
2.
2. And what about 4?
3.
3. Am I going to have 12s across the bottom here?
No, you can just cross them out.
Yes, you're right. I am going to have 12s across the bottom. So I can just cross them out preemptively and focus on the top. What's 12 times negative 2?
Negative 24.
What's 2 times negative 5b?
Uh,
Negative 10b, that's right. And what's negative 1 times 3?
3.
Negative 3. Right? Did we do that right? It looks like it. Negative 10b
Yeah.
Yeah.
minus 3. If I add 3, I get negative 21. It's a weird problem. I must have done something wrong there. Anyway, I'm going to add 3 over to both sides. Gives me negative 21 equals negative 10b. Even though my variable term is on the right, that doesn't matter. That's totally fine. Negative over a negative cancels out. And I get 21 over 10. Not 2 1/10. 21 over 10. All right. What I want you to do is take a couple minutes and see if you can see if you can work through all 3 of these. 3, 5, and 6. Take a couple minutes. I'm going to come by and answer any questions that we have. I just want to see if you guys are good on this and able to figure everything out on your own. So right now we're giving these 3 right here a try, right? On our own, just to self-check how we're doing. Great job here. All we gotta do now is simplify this. Oh, yeah. It's ugly. But you're right. Let's say 19 over 15. It should be, see that? It should be 12. Great job. term here is a negative. So you'll add 10 to both sides instead. Plus, that changes kind of what the answer is. This one you got 2 over 10. Okay. So for this one, what happened was you wrote 4 over 4, which is great. You got to do 4 times negative 1. I think you may have read it as 4 minus 1. See what I mean? It should be 4 times negative 1. Negative 4. It's all right. Really, really small mistakes. So we discussed 2 get 4b minus. So this was, I don't know, equals 4b. I'm not sure where the 6 came into play, but it was 8 equals 4b. We divide by 4 and we get a nice whole number. Super close. Great job. Okay, real quick, just so we can get started. Let's take a look. Number 3. What's my LCD in number 3? 6. So I'm going to leave my first term alone. This one's going to be 2 over 2. This one's going to get hit with a 3 over 3. I'm going to cross all my denominators out. Just look at the top. 5 equals 4b minus 3. Oops, it's super blurry. Now it's not. Right? Does that look okay? Yeah. I'm going to add 3 to both sides, giving me 8 equals 4b. And then I'm going to divide both sides by 4. What's 8 over 4? 2. Now you could keep it as 2 equals b, or just flip it around to b equals 2. Either way is fine. It's the same thing, right? Equal sign goes both ways. Anybody get 2 on their own for number 3? Click show thumbs. Thumbs up. You got 2? Very nice. Dropping it down. Okay, what do I need to do with this negative 1?
Put it over 1.
Put it over 1. Good, yes, turn it into a fraction. Exactly. What's my LCD in number 5? 4. So I'm going to multiply this term by 4 over 4, this term by 2 over 2, this term by nothing. Cross out my bottoms. I get negative 4 plus 10d equals 1. Add 4 to both sides to get 5 equals 10d. Divide both sides by 10 to get d equals 1/2. Right? 1 over 2. Anybody get 1 over 2 for number 5? Ooh, less people that time. No, never mind. More people that, or the same amount of people that time. Thank you. You just toss the paper. Now, number 6 is a little bit trickier. What's my LCD in number 6? 18. Good job. LCD is 18. Again, we focus on the biggest one, 9. Does 2 go into 9? No.
No.
Okay, so my next multiple for 9 is 18. Does 2 go into 18?
Yes.
Does 3 go into 18?
Yes.
Yes, it does. So I'm going to hit this one with a 9 over 9, this one with a 2 over 2, and what's my last whole fraction I'm going to use there?
6.
Beautiful. 6 over 6. Cross, cross, cross. 9 equals negative 10 plus 12n. Add 10, I get 19 equals 12n. Divide by 12, and I get the very, very ugly answer of 19 over 12. Even though it's ugly, we love it all the same. We're going to keep it as 19 over 12. Yeah?